I'm Mrs. K, and today we're going to look at factoring the greatest common factor. If I want to factor 3x squared plus 6x, first I want to look at my numerical parts, the 3 and the 6, and then the variable parts, the x squared and the x, to see what they have in common. 3 and 6 each have a common factor of 3, and x squared and x each have one factor of x. I'm going to multiply that by one more factor of x to get 3x squared, and I would take 3x times 2 to get 6x. So 3x times the quantity x plus 2 gives me 3x squared plus 6x, and I have factored it. 2x cubed y squared plus 8xy cubed. First I want to look at my numerical factors. The 2 and the 8 have a common factor of 2. X cubed and x each have one factor of x. Y squared and y cubed have two factors of y. I would take my 2xy squared and I would multiply it by one factor of x to give me 2x cubed y squared plus 4y would give me my 8xy cubed. It works the same for trinomials. The first thing we're going to do is look at 36, 24, and 12 to see what they have in common. Now your first thought might be that they each would have a 6, and that's true. But remember, we're always looking for the greatest common factor. So what we're going to do is we're going to factor out a 12. The x's have one factor of x in common. Y to the fourth, y to the third, and y have one factor of y in common. What would I multiply 12 by to get 36? 3. X, y cubed would give me my 36x squared y to the fourth plus 2y squared. And then I need a minus. And you might think I don't need anything there since I have a 12xy, but remember, we have to be able to multiply it back in. So I need to put a 1 there as a placeholder. If I take 12xy times 3xy cubed plus 2y squared minus 1, it would yield what I started with, and that's always our goal. All right, 18, 36, and 9 have a common factor of 9. X squared, x, and x have one factor of x. Y to the fourth, y to the third, and y, one factor of y. And z squared, z to the fourth, z, one factor of z. I'm going to multiply that by 2x, y cubed, z, plus 4, I have my x, I need a y squared, z to the third, minus, there's my placeholder again, of 1. Now we go look at this one, and we notice that 17 and 5 are prime numbers. So 17, 5, and 9 only have a common factor of 1, so there's nothing that we could really factor out. So you might think that it doesn't factor at all, but that's not true. We still need to look at our variable parts to see if they have anything in common. We have an x squared, an x, and an x cubed, so I can pull out one factor of x. I have a y to the fourth, a y to the third, but in my last term there are no y's, so I cannot take a y out of everything, therefore I cannot factor out a y. And then I have z, z to the fourth, z to the third, would have one factor of z. I'm going to multiply that by 17x y to the fourth plus 5, I've got my x, y to the third, z to the third, minus 9x squared z squared. When I multiply that all together, I'm going to get back the trinomial that I started with. And that's our goal. So, here's all the steps for factoring that you're going to learn by the end of the unit. Today, what we looked at is to always check for a greatest common factor. And step 3, does it factor again? In other words, did you check to see, did you take out the greatest common factor? And there you have it.